I'm Jag Srai, and I'd like to introduce a more systems approach to supply network design that we have developed here in the Centre for International Manufacturing, University of Cambridge. As you know, supply chains are about getting products to consumers right the way through distribution systems and back to the factories. And how do you design that? Well, actually, this is a complicated question. So we start to first look at the production process, trying to look at how new technologies would change the production process. We move across into areas around location of manufacturing sites. What's the optimum site for locating a manufacturing operation and the network of manufacturing sites? This could indeed include suppliers. Right the way through to the distribution centres that are best suited to store your product and supply on time. And finally, the resources that are involved in the whole manufacturing supply chain. So we have an efficient use of resources. Now, these complications in terms of technology choice, factory location, position of the distribution hub, and the resources that are consumed are complex challenges. And we find organizations typically address these as individual problems. Similarly, the modeling tools that are available treat these as specific questions to be addressed. But by taking a systems perspective, we connect conversations around the production process with those around production location, the scale of production, the optimum scale of production to support distribution, and finally, serving the end user in the most resource efficient manner. I would like to hand over to my colleague, Etre Satani, who will talk to you about these tools in a bit more detail. Over to you, Etre.
So as part of a Remedies project, we have created this collaborative environment in which we can really bring together different perspectives on global supply network from visual analytics and a data analysis perspective. The space consists of hardware. It's for multi-user interactive touchscreen tables, which are meant for small group learning and collaboration. And in terms of software, it comes with different tools that are industry grade and off the shelf. And these are tools with which most businesses are familiar, and that's why we choose them. Typically, each tool is implemented in isolation by specialists within the organization or academia. Now, what we bring in from our perspective is we stitch it all together. We make sure that a tool is just a layer of analysis, but each layer is connected to get the bigger picture. So we distinguish full layer of analysis, and we normally demonstrate it using a common case. So we start from what we call a macro layer, and that's where we look at the broader landscape that is relevant for an application. So typically we look at public domain data that come from public sources from, for example, about a sector or a country. With specific regards to pharmaceuticals, as we can see here, for example, we can look at authorization sources where we can see who makes a certain active pharmaceutical ingredient, in this case paracetamol. We can clearly see that none of it is made in the UK, but we can also see who's authorized to import that chemical into the UK. On the other end of the spectrum, we can also look at what's happening closer to the patient, so we can look at prescription. This visual analytics is based on NHS data. We can see how many scripts are released in a certain month, and then we can use this information to actually generate an estimate for the demand of a certain pharmaceutical product. In this case, let's say paracetamol tablets, 500 milligrams. And with this information about the manufacturing footprint and the patient behavior and the demand that is generated, we can then move to another layer of analysis. In this case, is what we call the meso layer or the network design layer, where we can actually bring this information in and start working around two main insights. One is what is the optimal sourcing strategy given the manufacturing footprint and given the customer demand. And the other one is about inventory profiles and service levels. In the pharmaceutical industry, especially managing inventory is a big topic. So the way we analyze that element is through simulation. So what we see at first is a map where we connect the dots we found at the previous stage, and those are sourcing possibilities. What we do, we navigate those possibilities based on scenarios. So there might be scenarios where it could be optimal to source from one source only, or if you introduce capacity constraints, then that's where, for example, the configuration of the network might change. So the key advantage of using this tool is to assess alternative scenarios. Then, if we introduce the economic aspect of it, we can easily compare different scenarios in terms of cost and actually make decisions. The analysis which brings about sourcing optimization, however, is static. If we introduce the time element, we can actually investigate alternative inventory profiles and figure out whether there might be backlogs or whether we might fail to satisfy demand when is needed. And most importantly, we can figure out whether the inventory we're holding is too much. So this is absolutely an absolutely crucial layer of analysis. However, the way the manufacturing footprint is connected, the time it takes to make things and what it takes to make things right actually is an information that needs to be generated through yet another layer of analysis, which we call the micro layer. It is where we focus on unit operations, manufacturing or service, and the technology that underpins those operations. When we talk about pharmaceuticals, the unit operations are typical of the process industry. So what we do here is we simulate a likely flow of material and lead time based on our current understanding of the chemistry and the equipment technology, as well as our understanding of the future, possible future, for example, through experimental data and new piece of kit. The key insights we take by running this type of simulation on manufacturing operations is actually a lead time estimate, which is crucial in order to assess whether a new technology is going to get things done quicker. And the second insight is about the bill of material, which actually will help us understand whether a new technology is going to generate more waste or have a better yield. And once we get that information, that might be very difficult to assess without assistance of these tools. We're then in a good position to provide accurate information, to feed accurate information into the meso layer where we evaluate alternative network configurations. Now, the last layer of analysis is what we call the product layer. And at this stage, we really need the results that we generated through both the micro layer and the meso layer. At the product layer, the analysis is slightly less site-specific and business-specific, but the emphasis is placed on extending the boundaries of the analysis so that we can really have an assessment from cradle to grave, possibly, of the environmental impacts of the technologies and the materials that characterize a certain scenario. So, in particular, what we can see here is an evaluation of different impact categories, not just carbon footprint, which is the most popular, but also, for example, human toxicity or eutrophication, which is normally affected by what type of technology might be characterizing certain locations, for example, a certain supplier location, And B, what are the technologies that are employed at the end of the pipe to actually deal with waste and emissions and treat them, because these technologies might have in turn important repercussions that we might want to take into account. So these were the four layers of analysis. We started from the macro layer, where we have been looking at data which is mostly in the public domain and characterizes certain sectors or countries. Then we moved to the meso layers, where we actually have been looking at assessing alternative network configurations in terms of optimizing sourcing policies, as well as evaluating inventory profiles. Then we moved to the micro layer, where we've been looking at unit operations and the technology that underpins such operations. And finally, we moved to the product layer that brings all together in order to provide an evaluation from cradle to grave of the technology and material that characterize a certain network configuration. Of course, there is much more to this, and if you're interested in knowing more, please feel free to get in touch.